Okay, so in the last video we discussed about logic coverage, and specifically in the case of logical expressions that are present in the source code of a program. And we also discussed about predicate coverage and class coverage in the context of logic coverage, and these are the two most simple coverage criteria in the context of logic coverage in programs. Today we are going to look at some more criteria in this context and some more useful stuff which will help you when you're trying to perform logic coverage of logical expressions in your source code. So first we need to look at the predicate coverage and the class coverage that may have some problems. And the first one is that predicate coverage do not fully exercise all the clauses which may be present in a predicate. It means that we don't need to change sometimes all the clauses to make the predicate true or false. And this is specifically true when we are doing short circuit evaluation. And if you are not aware of short circuit evaluation, what do we mean by that? For example, if I have a predicate like this, P or Q, in that case, and we know that P is having a value true, so then in this case it doesn't matter what value Q is going to have. So we can just look at P. If it is true, then this whole predicate will evaluate to true. So it doesn't matter whether Q is true or whether Q is false, the predicate will definitely evaluate to true. So we don't need to bother about Q. So that is exactly this problem, that predicate coverage does not need to exercise all the clauses all the time. And this you can also see in, if we have a predicate like P and Q, and we know that P is equal to false, then we don't need to bother or think about what Q is going to have, because this whole predicate is going to evaluate it to be false. So we don't need to actually evaluate Q in this case. So therefore there can be scenarios in which we don't exercise all the clauses, and this is not quite what we want when we are trying to perform logic coverage on our predicates in the program. And the second problem is that in the case of class coverage, this does not always ensure predicate coverage. So it may be possible that by changing the values of the clauses from true to false in the predicate, you achieve class coverage, but you may not sometimes achieve predicate coverage. In some scenarios you may achieve class coverage, but that may not be true in all situations. So that is also not quite that we want, as we try to have subsumption relation when we are talking about graph coverage or structural coverage graph relations. In that context, we define that edge coverage, for example, subsumes node coverage, and this edge coverage was subsumed by edge pair coverage, and so on. So if this is the case, that you achieve class coverage but we don't achieve predicate coverage, then this can be a problem, because we want certain coverage criteria, or those coverage criteria which do have some kind of relationship or other coverage criteria that can help testers. In that way they can say that if we have for example achieved class coverage, and if it is subsuming predicate coverage, then achieving class coverage guarantees that we have also achieved predicate coverage on the predicate. So this is not we want. And another criteria that can be achieved in this case is, or probably the simplest one or the simplest solution, is to cover all possible combinations. So what do we mean by that? It means we want to achieve combinatorial coverage, and combinatorial coverage requires every possible combination to be evaluated, and this is sometimes called the multiple condition coverage, or MCC. It is abbreviated as MCC. So what definition it has? Combinatorial coverage: for each predicate P in the set of predicates P. Test requirement has test requirement for the clauses in CP to evaluate to each possible combination of truth values. So it doesn't matter what clauses are there, you have to evaluate the predicate in terms of all possible truth values of the clauses in the predicate. So here is an example. We have this predicate here, which you can see on the right most column, and in the left part of the truth table we have all the clauses, and in the middle column you see this boolean variable D, and in the third column or the fourth column from left you see the third clause in the predicate, which was m greater or equal to n times O. Now we have constructed a truth table in this case for all, since there are three clauses, each clause can evaluate to either true or false. So you might know from discrete math or an earlier course in computer science where you have studied truth tables or combinatorial circuits, where you might have studied that when we have the three possible boolean variables or three possible clauses which can evaluate to true or false, we can have these eight possible values, and by taking into account these values we can have the values of the predicate in the rightmost column. So this looks quite cool because we have exercised all the possible values of the clauses, and we know how the predicate is going to have, what sort of values the predicate is going to have on all these possible combinations. So but this even though this looks quite simple and elegant, but this criteria also have a problem. And what is that problem? That this can be quite expensive. Why it can be expensive? Because you require 2 raised power n number of rows in the truth table, and where n is the number of clauses in the predicate. So this may work for maybe 2, 3 or 4 clauses, but when the number of clauses grow greater than 4 or 5, then it will be quite cumbersome to actually keep track of these tuples or rows in the truth table and look out values for each possible combination for the predicate, how the predicate is going to have that value assigned to it by the combination of these clauses. So the literature has lots of suggestions to overcome this, and some can be quite confusing. So the the general idea is simple: test each clause independently from other classes. So then we need to know what is the definition of the independent, or what is a class independence. So that we will look in the next video. Till then, thank you very much, and if you like the video, don't forget to